A probability related to medicine and whatnot is like testing for a disease or drug testing or any kind of test you can do on a population where one part of the population has the sickness, disease, uses drugs, whatever, and the other part of the population does not. So let me go back to the slide I really want to talk about is this one. So this one I just kind of made up. It's about tuberculosis. So either a population has tuberculosis or part of the population that does not. And then you have a test for it, and it tests positive for some people and it tests negative for some people. But a lot of people think when a test positive happens that more than likely you would have the disease. And that's not always the case, so you have to be careful. Like for instance here, 85 people have tested positive for TB that actually have tuberculosis, so we call these the true positives. Oops, spelled that wrong already. True positives. And over here we have 23 people that tested positive for the disease, but they really don't have it, so these are called false positives. Yeah, false positives. Alright, then down here we have a person that has TB, but they tested negative. Well, if they have TB, they really should test positive. So this one is called a false negative. They really should have tested positive, but they didn't. And then here we have this 96 people that do not have TB, and they definitely tested positive or negative for not having TB. So these are what are called true negatives. Alright, so knowing these names helps us do some of the rest of it. The advertisement on a box, like if you buy it at Walgreens or whatnot, a pharmacy, is going to talk about the sensitivity, how accurate the test is, and it's usually based on sensitivity. Sensitivity is if you are a person that has TB, what is the probability that you are going to test positive? So this is known as a conditional probability. Because you're not looking at the entire population anymore, you're only looking at the people that actually have TB in this case. So you're subgrouping it away from the entire population. So we're looking at the subgroup of people that already have tuberculosis and the percentage of them that actually has the disease that test positive. So this one would be, the sensitivity would be 85 out of all the people that tested positive. So it's the true positives out of, it's the true positives out of all of the sick people, the true positives and the false negatives. So it would be 85 and the 12. Oops, 12. So this would be 85 out of 97, and this is equal to 85 divided by 97. So this test is going to find those people that actually have tuberculosis 87.6% of the time. It'll test positive for those that actually have it. Specificity, on the other side, is talking about how well the test is for finding those that do not have tuberculosis. So you go over here to those people that are not sick, and you find out how many of them are the true values in that column, in this case the true negatives. So this would be 96 out of the 96 that are true negatives, plus those 23 that got tested bad, the false positives. So this becomes 96 out of 119. So the probability that the test is going to catch that you are actually not sick when you are not sick is actually going to catch it about 80.7% of the time. So the test will show that you do not have the disease if you really don't have the disease 80.7% of the time. So this one is mainly used on the sensitivity of a drug test if you buy it at Walgreens. And they're usually like 95%, so that's what most people consider the accuracy of the test. But it's only accurate if they really, really actually do take or do use the drugs or do have the does have the tuberculosis in this case. So another measurement to take care of the possibilities of something else is this setup. And the difference between this setup is this. 85 plus 12. In this population, 97 people have tuberculosis and 119 do not. But over here we have 30 people that only have the disease and 96 plus 15, 111 that actually do not. So the difference here is what's considered prevalence. How prevalent is the disease? How prevalent is drug usage in a population? And that's going to determine whether the test is actually going to be very accurate or just somewhat accurate. So prevalence, where sensitivity and specificity were working with the columns, prevalence is going to be looking at, if you test positive, what is the probability that you actually have the disease? So we're going to be looking at the rows this time, just all the positive tests. So that is called PPV. Positive predictive value is the fancy acronym. Positive predictive value. So it tests positive 85 times here out of 108. So the PPV of this test is 85 divided by 108 for 78.7% of the time. If you test positive, you really do have the disease. That's a little bit different than saying if you have the disease and you test positive. That's how specific the test is designed for. This is saying that the prevalence of a test positive is actually going to be a little bit lower. So I would say if you tested positive, you have a 20% chance of actually being in this part of the world. Alright, if we do the NPV here, that would be the negative predictive value. Then we're worried about the negative test, so we're looking at these numbers. So another conditional probability. And we're looking for the true negatives, 96. It's always the trues that go on the top, divided by 108. That's interesting. They're both 108. I didn't plan on that. So this would be 96 divided by 108 for 88.9%. So out of those that test negative for this, about 90% of the time it will be a true negative. Alright, so let's see what happens. What's the difference between the one on the left and the one on the right? And the difference is this. This side has about as many sick people as it does healthy people. This side has fewer sick people and a lot more healthy people. So the prevalence is much more prevalent to have tuberculosis in this population than it is to have it in this population. This would be like the Philippines compared to the United States. Tuberculosis in the United States is very rare, 4 out of 100,000. Where over here, like if it was the Philippines, I think it's around 4 per 10,000. So it's 10 times more likely in this side. Alright, so let's do the PPV of this side. PPV. And remember, PPV is the test true positives out of all of the positives. So this will be 23 out of 38. And you'll find that this percentage is much higher. 23 divided by 38. Nope, I'm sorry. Lower. So this one is 60.5% of the time. And the NPV is going to be the true negatives out of all the negatives. So you're looking at just the negatives, and the true negatives, which is 96, divided by all of the negatives, 103. So that would be 96 divided by 103. So this would be 96 divided by 103. 93.2% of the time. So what this is saying is this test will show that you are healthy 93.2% of the time, which is better than over here at 88.9%. So because the prevalence of the disease is higher, the NPV is going to be higher. And then if you look at the other number, The 60.5 is because there's not that many sick people in this test. Therefore, the percent of getting a sick person to test positive is going to be lower. Where over here, having more sick people compared to the entire population raises the PPV of the percentage. So this number will tell you the prevalence of the disease and the accuracy of the test all in one, which is kind of nice. Now let's take all those conditional probabilities and put them to work. So a new drug test has been developed and tested. This test has a 99% sensitivity and a 95% specificity. Given that it is going to be used at a high school where the administration believes that 3% of the 1,500 students use drugs, find the PPV and the NPV of this test. Should a parent confront the administration if their child is tested positive for drugs and they're like in danger of getting kicked out? So let's break it down into what we need to know. When we set up the chart, how do I get to it? There it is. When we set up the chart, we're going to have, the test positive for the drugs, test negative for the drugs, the kids actually do drugs, and over here you have the kids that don't do drugs. And the only thing that it relates to the number of students and this table is this sentence right here. 3% of the 1,500 students use drugs. They probably base this opinion on some study of high school students. So the first thing you need to find out is how many are using drugs. So drug users. And this is going to equal, well, literally the 3% of the 1,500 students. So let's see here, 3% of 1,500, 0.03 times 1,500, 45. So out of that 1,500 students, you can expect 45 of them to be using illicit drugs. Now, that doesn't go into the table per se, but it does give me a total of the total drug users. So I'll put that down here as a reference number. Alright, now if 45 of them are using drugs, then the other ones must not be. So 1,500 minus 45, that leaves you with 1,455 over here. Now the prevalence here is very, very low compared to the entire population. So we would expect the PPV and the NPV to catch this. Well, we would hope so. Alright, we need these numbers in here to come up with the PPV, the positive predictive value, and the NPV, the negative predictive value. So we need these two numbers. So to get to that, we're going to use the sensitivity and the specificity. So if it has a 99% sensitivity, that's pretty high. It's going to catch the drug users 99% of the time with only 1% of error. So we're only talking about these guys. Out of the 45 that actually do drugs, this is going to catch 99% of them. So the true positives is going to equal the 99% of these 45 students. And we'll round it to the nearest student. So let's see here, 0.99 times 45 is 44.5. Let's round down so we can at least have one negative test. So test positive, 44. Test negative, maybe 1. Alright, so that would add up to your 45. Now to find the does not do drugs, we're going to be looking for the true negatives. The ones that really don't do drugs and tested negative for the disease, the drug usage. So we're going to use the specificity. So that would be 0.95 times the entire population of the ones that do not do drugs, that 1,455. So 1,455 times 0.95, 1382. 1382. So this would equal 1382. And we would put them here, 1382. And that leaves 14455, well, 1455 minus that for 73 students up here. Okay. So let's find the PPV of this. The positive predictive value. If your tested positive, what is the probability that you actually use drugs? So that would be the true positives, 44, over all of the positives, which would be 117. I better double check my mental math. Oh, never been good at that. Yeah, 117. So 44 divided by 117 is 37.6% of the time. This test, used on this population, is going to test positive 36.7% of the time accuracy. So if your child is tested positive for drug use, according to this test, because the prevalence is so low, this is starting to sound more like they probably don't, because it only catches it true 36.7% of the time. Now NPV, the negative predictive value, if the test comes out negative, then 1382 divided by 1383, I mean that's all there is one more. If the test comes out negative, 1382 divided by 1383, plus that 1 that I threw there, just so I had a number to play with, it should have been 0. This thing would have been 99.9% accurate. So in other words, in this population, if the test was negative, pretty much you can guarantee that the test is accurate for those negative tests, but not so accurate. So if I was a parent and my child was tested positive for drugs according to this test, even though it had a 99% sensitivity, I would argue that more than likely my kid really didn't do drugs according to the PPV.